Welcome to our channel. So today we'll be discussing about electrophoresis and we'll try to solve some of the numerical problems of electrophoresis. And I have mentioned a question, and this question is derived from exam paper of 2019-20 of Kingston University. So that's the question. If you see the paper, you will find that's the question 15 part B, and here is the question. So first we'll try to understand the question and write the data in particular form. So the two proteins, myoglobin and ovalbumin, have relative molecular masses of 21,300. So we are given with two proteins, one 21,300 and the second one is 51,000. And their migration rate is 7.5 and 3.3 centimeter in the gel. And then we are given with an unknown protein, that is α-chymotrypsin, and its molecular mass is 27,800. So we will write in a way. So here we are given with two proteins. One is myoglobin and one is ovalbumin. Its molecular weight is 21,300. Its distance travel is 7.5, 51,000, and 3.3 centimeter. Then we are given with α-chymotrypsinogen, and its molecular mass is 27,800. And we have to find the distance traveled by this protein. So we have to decode the whole data that is given in the question, and then we'll try to solve this question. So here is the formula that we will use to solve this problem, because we are given only two proteins, and that's the third protein that we have to find. If there are only two, three standard, then we will use this formula to find out the distance travel by the third protein or the molecular. If the distance is given, then we can find the molecular weight of the third protein. So these are only three proteins, so we have to use this formula. So for myoglobin, I have write the same over here, and then for the ovalbumin I have right over here, and then we'll try to insert these values into the formula and find out. So we have placed the values, like for myoglobin distance is 7.5 and its molecular weight is 21,300. For ovalbumin we have to follow the same steps. So the question arises, like, why can't we just place the value of the molecular weight of the α-chymotrypsinogen in this formula, because A and B are unknown. And to find the value of A and B, we have to use this data to find out the values of A and B. And we're going to find out the values of A and B from this relationship. The second thing that you need to remember is that when you take the log, there's the log 10. You have to take the simple log. You need to put in calculator. I will show you. So you have to place values like this one, the normal log from the calculator. You don't have to press any shift, anything. You just press log and then place the value over here, and then it comes up to the values, final value, that is 4.32 in this case. Here when we place the values, that's log of 21,300, that become 4.32, and 51,000, that become 4.70. And when we arrange this equation, to find out the value of A, that becomes 7.5 plus 4.32b, and over here 3.3 plus 4.70b. As you know that the left hand side of the equation is same, so we can compare these values, 7.5 plus 4.32b with 3.3 plus 4.70b, to get the value of b. So when we place these values, when we compare these values, it will become like we have to move 3.3 on this side. So when we move 3.3 on this side, it become negative. So 7.5 minus 3.3, that become 4.2. And similar 4.70 minus 4.32, that becomes 0.38. And when we divide 4.2 by 0.3, that become 11.05. So we have to use this value, b value, and we can place it any of the equation, either this one or this one, to get the value of a. So when we place the values of the b in equation a, so equation was like 7.5 plus 4.32b, and the value of b is 11.05, and that become, when we multiply this one, 47.73, and when we plus, that's become 55.23. So we got the value of a and b, and we use the same expression in the, as I have explained in the first phase of the lecture, and we use the same expression to find out the value or the distance traveled by the α-chymotrypsinogen. So for alpha-chymotrypsinogen, A is 55.23, B is 11.05, molecular weight that is given in the question, that is 27,800, and we got this relationship. Now we just need to place these values A, B, and this molecular weight into this equation. So when we place these values into this equation, it becomes 6.12 centimeter. You can do this and just one calculation using the calculator. And so the distance traveled by α-chymotrypsinogen is 6.12 centimeter in the same gel. So that's how we're going to solve the question. If the two proteins, their molecular weight and their distance travel is mentioned, and we can find out the distance travel of the third protein, or if the distance travel of the third protein is given, we can find out its molecular weight using the same formula. If you have any question, you can ask in the comment section. Thank you so much for watching.